Show that a cube cos b minus c plus b cube cos c minus a plus c cube cos a minus b is equal to 3abc. Now here in the solution, taking LHS. So LHS what we have, so a cube cos b minus c plus b cube cos c minus a plus c cube cos a minus b we have. So now, so here this is considering using sigma, writing here, taking only one term. So sigma a cube cos b minus c. So further it is writing as, so sigma a cube writing as a square into a cos of b minus c. See, by sine rule we know that, so small a is equal to 2r sine a. So now here, so this a square writing as it is, and the small a replacing by 2r sine a into cos of b minus c. So now here a square r considering sigma a square r into 2, so sine a, so sine a writing as 180 minus of b plus c. So why? Because we have here, so a plus b plus c is equal to 180, a plus b plus c is equal to 180 we have in a triangle. So from this a can be written as 180 minus of b plus c. So that's why here a is replaced by sine 180 minus of b plus c. So now if you observe, it is like sine 180 minus theta. We know that sine 180 minus theta is equal to sine theta. We know that sine 180 minus theta is equal to sine theta. So that's why theta is here b plus c. So it can be written as sigma a square r into, this is 2, so here this is sine b plus c we get into cos of b minus c, is it? So now if you observe here, it is in the form of like 2 sine a cos b. Here a if you treat b plus c and b if you treat b minus c. So now it is in the form of like 2 sine a cos b. We have the formula for 2 sine a cos b. So what is the formula for 2 sine a cos b? So sine a plus b plus sine a minus b. So now here, which is equal to sigma a square r, here sine a plus b, that is can be written as sine of a is b plus c plus b is b minus c here. So b minus c, so a plus b, sine of a plus b plus sine of a minus b. So a is b plus c minus of, this is b minus c. So now further it becomes now sigma a square r into, here observe that here sine of cc gets cancelled here, we get sine b plus b is 2b, and here if you observe b plus c minus b and plus c here, if you multiply with minus, so plus b minus b gets cancelled, we get c and here plus c, so it becomes sine 2c. So further it is in the form of like sine 2 theta, so we can continue that. So here sigma a square r sine 2b plus sine 2c, so which is in the form of like sine 2 theta. So sine 2 theta is, we have 2 sine theta cos theta. So now it can be written as sine 2b is also can be written as sigma a square r into sine 2b can be written as 2 sine b cos b, like sine 2 theta, and here sine 2c is also can be written as 2 sine c cos c. So why it is in the form of like sine 2 theta? Sine 2 theta is 2 sine theta cos theta. Now further what I am doing is these two terms multiplying with this r. So now sigma a square into, if you multiply, it becomes 2r sine b cos b, and here plus 2r sine c cos c, if you multiply with r. So now if you observe here, 2r sine b, from the sine rule we have small b, and 2r sine c we have from sine rule small c. 2r sine b here. So and small c is equal to 2r sine c. So we can write. So that's why here this 2r sine b is replaced by small b, that is a square into, so here b cos b, and here plus 2r sine c, so that is replaced by small c, so cos c here, small c cos c. See, observe here, a square is there, we are getting b cos b plus c cos c. So first what I considered the first term only, no? Now I am expanding the sigma. Now we get here a square, the first term is a square b cos b plus c cos c, c cos c, and next term, for the next term we get here b square. So here continuation the term will be, that is c cos c, c cos c, plus next a cos a cos a we get. So next term is c square. So for the third term, c square. Now continuation from here, that is a cos a plus b cos b. See, observe carefully. Now here, if you multiply these terms, these two terms with a square, then we get a square b cos b plus a square c cos c, a square c cos c plus, again if you multiply next these two terms with so b square, that is b square c cos c plus b square a cos a. So plus again if you multiply these two terms with c square, we get c square plus c square a cos a plus c square b cos b we get. See, observe here, the first term is here we have a square b cos b, and here a square b cos b, the first term, and here so we have b square a cos a. So from these two terms taking ab common, from these two terms taking ab common, then we get ab when you take common, so we get here a cos b from this term, and from this term we get b cos a plus, again here if you observe, this is a square c cos c, and here c square a cos a. From these two, if you take here, so ac common, clearly ac is common from these two, AC is common. So here we get a cos c, and from this you get c cos a, we get c cos a, and plus suppose at last we get these, so we have these two terms, b square c cos c and c square b cos b. From these two we can take bc common. If we take bc common here, from this term and this term, we get b cos c, so plus here c cos b we get. Observe carefully. So now I have taken ab common from these two, and from these two I have taken ac common, and at last from these two I have taken bc common. See, observe carefully here. So within the bracket here we have AB, and here if you see that, so A cos B plus B cos A, there is no small c, so that's why this is small c. So plus here AC AC. Here if you observe, this is a, so there is no small b, so that's why we can write small b here, and plus a BC into, here if you observe, so there is no small a, so that's why we can write small a. See, actually by projection rule, we have one rule, by projection rule, we have here small c is there, no, that means small c is equal to a cos b plus b cos a. Small b is equal, small c is equal to a cos b plus b cos a. Similarly, small b is equal to here a cos c plus c cos a. C cos a, for your understanding I am explaining, these are all writing. Small a is equal to here b cos c plus c cos b. Observe here carefully by projection rule. Finally, what we get here, ABC this is, and this is also ABC, and this is also ABC. So that's why ABC plus ABC plus ABC we get 3ABC. So which is only the RHS. This is only we have to prove that. So therefore LHS is equal to RHS. So like this we can prove the solution.